This one we talked about, I think in 6th grade, when we learned integer rules. So 6th grade, maybe 7th grade, 7th grade. Oh, how about I finish the word first? Definition of subtraction. What did we do when we subtracted integers? What do you do to complete a problem like 7 minus -2? Luz, how do you do that problem? What did we do? What did we do here? What did we do to figure out the answer to this? What is the answer to this? Stop singing, whoever's doing that. 7 minus -2. No. Why? Because this turns to a plus, and this becomes I can't hear what you're saying. What does the -2 turn to? Positive. Now what's the answer? Oh, it's 9. So, let's do this. Okay, I already asked you to stop humming, so whoever's doing it can stop. Every time we had these kinds of problems, subtracting is the same as adding the opposite. Okay? We use that a lot. We'll go along the same things. Wow, this one is not very good one. Can you kind of see what I did with the definition of subtraction? Which, by the way, it's not the definition of the word subtraction. The property itself is definition of subtraction, and this one is definition of division. Based on what Angela did just a little while ago, dividing two numbers is the same as Caleb? Your hand was up, I thought.
Yeah, it was.
Rashawn?
Combine the opposite.
Mm-hmm. Multiply by the reciprocal, right? That's what we just did in that equation a little bit ago. Dividing is the same as multiplying the reciprocal. So 6 divided by 5 is the same as 6 times 1/5. We would most likely see it as 6 divided by 5 is the same as 6 times 1/5 in that way. But it's the same thing. I think I'll put the other 3 in the middle, because those are new. You've never seen them before, really, or never had reason to see them before. Okay, the reflexive property is super easy as well. That's what it is, and you might think, why in the world do we need a property like that? That something equals itself. X equals X. 2 equals 2. Well, Those properties become more important when we're using properties to solve proofs. When you get into high school and you have to do proofs, they're not fun, I'll tell you that. Most of the time, they go through maybe some of these properties and you have to do algebraic proofs. That's not too bad. But when you do geometric proofs, there are so many properties. Here's different names for properties. Properties, axioms, postulates, theorems, all of those things pertain to different aspects of triangles and shapes and stuff like that. And you kind of have to end up knowing those. It's not fun and not super easy. But at least you'll have a heads up on the algebraic proofs because we'll be looking at them. But something like this usually sets up something. Like if I say, I want to prove that, well, I'll get to that later, actually. We'll do the proofs part later. I don't want to mess you up. All right. Next one is called symmetric. You see the word like symmetry, right? Similar, something like that. First of all, this property starts with an if, most of the time. If A equals B, then B equals A. It kind of looks like a commutative property, but you notice there's no operations going on there. It's just saying that an equal sign is kind of able to be flipped, right? 3 plus 2 equals 5, then 5 equals 3 plus 2. You notice I didn't change order of things or whatever, I just like flipped the two sides of the equal sign. And the last one, yay, we got to the last one, is transitive. So this one kind of was looking at a reflection, kind of. This one had to do with similar or symmetry on, you know, it's kind of same thing in a different viewpoint. Transitive, the only thing I have to help you with is that it starts with a T, and a T helps us remember 3 parts. There's 3 parts to this property. You're going to help me fill in the last one. If I say A equals B, and I also say, and B equals C, then what can you conclude? Read through that. If A equals B, and B equals C, what do you know? Evelyn?
Then C equals A?
Yep. See, if it's like it took 2 steps to say that that one equals that one, okay? I guess I'm trying to get too technical. There's, I don't know if I have it. But what we're gonna do is we're gonna look at these kind of examples and be able to identify which property is going on. Okay? I'm gonna wait until you're done writing that, and I just wanna write one more thing. Good. property is being used. I wanna look over here, like if this is the problem they're giving me, what changed from the left side to the right? Well, the 4 multiplied by the x and the 4 multiplied by the 1. Oh, okay, that helps me. What happened here? Well, the 6 plus 0, the 0 disappeared and it stayed a 6. What happened here? 3 plus 5 became 5 plus 3. So you're in your mind, you're actually asking yourself, what physically changed? And then see which property lets you do that. And it seems like a logical course of questions, but it's gonna get a little, jumbled at first, like which one's which.